sends this message to the server. This client hello message contains the cipher suits that we had talked in the. Welcome everyone back to the channel. How are you guys? Today we will discuss the most important TLS 1.3 handshake. So let's go ahead. Let's see how TLS 1.3 handshake works. First of all, client generates the client hello message. Now this hello message contains client random value, the requested key exchange mode and the supported ciphers in TLS 1.3. Along with this, client also generates the pair of ephemeral public and private key, and public key is part of client hello message as well. Finally, client sends this message to the server. Now in response, server generates its own server hello message, and this server hello message contains the server random value, the selected cipher suit and the server certificate to prove its authenticity to the client. Similarly, server will also generate its own pair of public and private key which are ephemeral, and it will send it as a part of server hello packet. Now once the client receives this server hello packet, it will verify its certificate and say that it's ready to encrypt the data using symmetric key, and it will send it as a part of client finish message to the server. Now as soon as this message is received by the server and client has already verified the server authenticity using the certificate, it will generate the symmetric key using the HTTPS function, and the interesting thing is this key is never shared on air. So what will this HTTPS function take as an input? So HTTPS function will take the client random value and the ephemeral private key of the client, and it will have the server random value and the server public key, and finally using this things as the input and the SHA of the both the handshake, the client hello and the server hello, it will generate the symmetric key. Similarly, the HTTPS function will be used by the server as well. Server will use the client random value, the client's public key and its own private key and the server random value to generate symmetric key, which will be used for the further encryption. So finally, both of them has generated a symmetric key. Now whatever is sent after this three-way word handshake will be all encrypted. If the client had requested for the PSK, that is session resumption in TLS 1.3, server will send this 2 session tickets which can be used by the client to resume the session in the future. Let's see live how TLS 1.3 handshake works using Wireshark. So we'll use this command of OpenSSL and we'll try to connect to a website cloudflare.com, and we'll intentionally make sure that we are doing TLS 1.3 handshakes connection. So the moment I press enter, you see here we'll have this client hello message and the server hello message. This client hello message contains the cipher suits that we had talked in the presentation. It has 4 sets of cipher suits. Now here down the line you will find the ephemeral the public key which of the client. In response, the server now sends the server hello message. If you'll see, so the server hello message in the same way it contains the cipher suit it selected, and it has the server's ephemeral public key as well. And finally we send this the client finish message to inform the server that we are ready for the encryption. After this, whatever packets we see are encrypted using symmetric key, and we can't. So if you see, the last 2 packets are a set of post handshake new session tickets that arrived, which is so you see there are 2 tickets received. So we have these 2 handshakes from the one from the client end. So we have this post handshake new session ticket arrived, and finally this for the connection termination. So yeah, this is how, and we can use this OpenSSL command to read, understand what we received. Like if you see here, it will tell you which the client hello message is this, the server hello message came like this, certificate size, everything you can decode using this OpenSSL command as well. And one thing